Hi, I'm Chris DiMartino, and welcome to the Short Waves video on substrate scalability of Modelithics Microwave Global Models in Cadence AWR Design Environment. Let's get started. Substrate scalability is one of the main features included with Modelithics Microwave Global Models for capacitors, inductors, and resistors. This feature is significant because a component's high-frequency performance strongly depends on the substrate that it's mounted on. Let's demonstrate the substrate scalability feature of Modelithics Microwave Global Models by looking at the model for the Johansen RO7S capacitor series. We'll begin by looking at the datasheet for this model. Notice here that we have this model features box. Inside, you'll see that substrate scalable is listed as one of the features. You'll also see this H/epsilon-R ratio, which is how substrate scalability is quantified. H refers to the height or thickness of the substrate the part is mounted on. Note that the H value is defined in mils. Epsilon-R refers to the substrate's dielectric constant. A model is validated for all substrates that fall within the H/epsilon-R ratio specified in the datasheet. This validated range is determined by measurements that were performed using different substrates. This model that we're looking at is validated for H/epsilon-R ratios between 1 and 16. Let's simulate this model using different substrate heights to show how the response changes. We'll simulate from DC to 10 GHz. A microwave global model requires you to specify a substrate. In this case, the substrate that we're specifying is this microstrip substrate definition shown here. The H or height parameter of the substrate definition is set to a variable. So we'll go ahead and simulate the model while sweeping the substrate height value from 10 to 55 mils in increments of 5. Since the epsilon-R parameter of the substrate definition is set to 3.5, we're actually varying the H/epsilon-R ratio from 2.857 to 15.714. This range of values falls within the model's validated limits. These are the simulated S11 and S21 results over the range of substrate height values that we specified. Note that the capacitance value of the model is set to 3 picofarads. We can clearly see how the performance changes with respect to the substrate height, so this simple demonstration shows the significance of performing simulations with substrate scalable models. We can further demonstrate substrate scalability by looking at a simple filter design example. This is a low-pass filter design that includes microwave global models for Presidio 0402 UP capacitors and Coilcraft 0402 HP inductors. We can first set each model to ideal mode. When we set the component models to these values, we see this response after simulating. Now we'll change the models to full parasitic mode to allow them to account for device parasitics, substrate effects, and solder pad effects. We'll simulate this filter using 3 different substrates: 4 mil thick Rogers 4350B, 20 mil thick Rogers 4003C, and 60 mil thick Rogers 4003C. We'll use the same component values used in the simulation with the ideal models. Here are the simulated results. For reference, we're also showing the simulated results of the ideal filter shown earlier. We can clearly see the shift in the frequency response due to using full parasitic models. Also notice how each substrate produces a different response. We can go through the process of adding microstrip interconnects and vias. We can then perform EM circuit CoSimulations for each filter, and then we can tune the component values to match the ideal response. Here we can see the final EM circuit CoSimulation results of each filter after properly adjusting the component values. For reference, we're also showing the initial ideal response. As you can see, the performance of each filter matches the ideal response. These are the final part values for each filter. Notice how each filter requires its own unique set of component values to achieve the same response. So this demonstration further emphasizes the importance of using substrate scalable models. Well, that concludes this video. For more information or to request a free trial, visit www.modelithics.com or email sales@modelithics.com.